Hello, welcome to the game theory course. This is lecture 21, and I hope that you would find the new PPT at the YSEC, which my TA has posted, I think today. So you will find out. I saw him posted it. Anyway, this is the last class of week 7. Okay. You remember we were doing the subgame perfect equilibrium, and I explained the basic things: the first mover, second mover, and empty thread, and the commitment problem, and burning the bridge behind, and also maybe importantly, if you take the exam, this equilibrium path and non-equilibrium path. So once again, this is kind of rediscovering the real meaning of equilibrium. In equilibrium, it's not enough to just say this will happen, and you have to explain why that happened. That is why you have to describe correctly the non-equilibrium path, because more often than not, what could have happened in that non-equilibrium path is the reason why the equilibrium path happened. Okay? Probably you remember that I have advertised that the subgame perfect equilibrium would part a huge portion of this game theory lecture. Maybe if you go to the graduate course, the other concept would be more important. But undergraduate course level, this fully understanding subgame perfect equilibrium would be really important, and it is very useful to applying for our lives. So even though you don't have no plan, you have no plan to be the scholar or economist in your life, but understanding subgame perfect equilibrium would be helping you, I'm almost certain, at some point of your life, because this is the basic concept, living this kind of a tough jungle out there kind of situation. Okay? So, apart from the theoretical part, I'm gonna take 3 important examples of the subgame perfect equilibrium application, and you can be the judge by yourself. The first one is the bargaining game. Okay, negotiation, bargaining, it is happening everywhere. Like you are bargaining with your parents, like what to do, can I have this clothes? Can I have more money for this weekend? Can I have this boyfriend, that girlfriend? Your parents are trying to involving you, but you don't want to, and you're bargaining with your boyfriend, girlfriend too. I'm bargaining with my son, and I'm bargaining with my wife. Okay, so this bargaining game is everyday life important thing. However, I'm bargaining with the student too. Like many of you ask me, like, can I get into your class, or can you like raise my grade and things like that. So that is our bargaining to me. So like you cannot leave a day without a bargaining, in my opinion. And then this bargaining game, not everything about bargaining, but the essence, basic of the bargaining game can be understood using the subgame perfect equilibrium. Number 2 is the repeated game. Most of the game I explained until now happen just once. You play rock, scissors, paper game with your friend once. That's what we analyzed rock, scissors game, paper game. But what if you're playing rock, scissors, paper game every day with someone? Like I'm playing rock, scissors, paper game with my wife every day for the rest of my life, in order to decide who's gonna clean the floor, who's gonna clean the dishes every day. So I sometimes win, wife sometimes win, but it's gonna be forever until one of us die. Okay? Then the thing may change. I mean, playing rock, scissors, paper game once with someone you don't know, playing rock, scissors, paper game every day or every hour with your family members like your wife, they are different game. You would understand that when you get married. Because, I win too many times, but then maybe this time I want to lose kind of thing. So repeated game has whole new word in it. And then we are gonna look at that. So it's a like long relationship and short relationship kind of thing. So the game would be repeated over and over again means with that specific player, you are going to have a long-term relationship. Okay? How does that change? Principal agent game. Principal agent game, as you know, I'm working for the President Seung-hwan, right now, and actually, you are paying money to the president of Yonsei University, but then the president cannot teach all like dozens of thousands of students by himself. So he kind of hire me, professor like me, to teach you in place for him. Okay? So you go to the restaurant, there's a waiter and waitress. Usually they are not the owners. Okay? What are they doing? There's a restaurant owner and he cannot do everything. So he hires someone, we call that agent. The owner is a principal. The waitress, waiter, they are the agent. And then, the agent work for the principal. I work for the president of Yonsei University, something like that. And, the principal expect the agent to work hard. The president, Yonsei University, expect me to work hard. Am I? Well, we will see. And I'm just getting paid. Why in the world would I work my butt off? Because it's not my business kind of thing. And that kind of situation can also be very well explained by subgame perfect equilibrium in basic. Okay, so all these three very realistic, very important games has something to do with subgame perfect equilibrium, and we are gonna spend a whole lot of week to analyze this. Let's begin with the bargaining game. Okay, I'm gonna explain a setup. Now, because Tom and Bill appear too much, now I change them with ladies. That is Sarah and Jane. Sarah and Jane have a class at 1 p.m. 1300, 1 p.m. Okay? Pizza is delivered at 12:30. They ordered pizza or the school ordered them a pizza. So one pizza is delivered to them 30 minutes before the class. The problem is, not the problem, but if they do not eat the pizza right away, the pizza is getting colder and colder. How can I express this? At 12:30, when the pizza has just delivered, the whole pizza's value is 100. If Sarah, just one person, eat the whole pizza, she will get the happiness payoff of 100. If they divide it half and half, Sarah and Jane, Sarah gets 50, Jane gets 50. But then, the same pizza 10 minutes ago, 12:40, got a little bit colder. As a result, even though it's the same whole pizza, the value would be 70. So if Sarah eats the whole pizza at 12:40, instead of payoff 100, she will enjoy 70. If Sarah and Jane divide it half and half at 12:40, it's 35. Likewise, 12:50, the value is 40. If Sarah and Jane wait 20 minutes after the delivery and eat the pizza, each would enjoy 20/20 because the sum should be 40 when time is 12:50. Understood? This is very realistic. Think about that. Like you want to move into the apartment. Sarah want to move into the apartment, and the apartment owner is Jane. And Sarah said, "Oh, can I pay 1,000 US dollar per month for the rent?" Jane said, "No, no, no. You should pay me 1,500." Sarah said, "Come on." And they argue, they negotiate, bargain like 1 month. What happened? Still they are negotiating. First of all, Jane has an empty apartment, but then the whole month of September, nobody got in. So Jane lost the rent for the September because Sarah didn't move in. Okay, so Jane loses because why? The bargaining is getting longer and longer. So when the bargaining gets longer, Jane obviously, if it takes 2 months, then 2 months rental fee, 3 months, 3 months rental fee. So if you think the apartment owner who want to rent the fee would be in a very good position, but then she couldn't get that rental fee for several months, she would be in a trouble. So Jane wouldn't like Jane wouldn't like the pizza to get colder. Jane would not bargaining for a long time so that her apartment would be empty for a long time. What about Sarah? Oh, she doesn't own an apartment. So even though she lost the whole September, she has nothing to lose? No. Sarah wants to move into that apartment. Why? Because she does not have a home. Probably she's staying at a hotel or relative's house. Hotel, you have to pay. Relative's house, inconvenient, and then probably you have to give some gift to the relative, something like that. Therefore, both Sarah and Jane, if they cannot resolve the bargaining game as soon as possible, the more time they spend, their payoff would decrease. That's kind of why I set this assumption. Pizza getting colder and the value gets lower and lower. Very common in any bargaining game. If the pizza does not getting colder, or if it gets colder, the taste is the same, then maybe one important element of bargaining would be changed. That is, oh, I can bargain forever, kind of thing. Okay, we are going to talk about that a little bit later. Sarah and Jane negotiate. Basically, they can negotiate every seconds, but then that would be too much because that would be like millions of strategies we have to talk about. I'm just going to assume that they negotiate 3 times. 12:30 as soon as the pizza delivered. For 10 minutes they never they negotiate, and 12:40 they negotiate, 12:50 they negotiate. If they fail to make an agreement at 12:50, as I said, they have a class at 1300 and they have to get into that class if they don't want to get flunked. So they cannot eat the pizza because there's no agreement, no pizza. Okay, so 12:50 is the deadline. If the pizza division was not agreed by 12:50, then they go to the class and nothing happened. Both get 0 and 0. The pizza goes to the wastebasket. Here, I have some restrictive assumption that is one player makes offer and the other accept it or reject it. How do you negotiate, basically? With my wife, I said, oh, I'll cook, so you should clean the room. That's how we negotiate. It's like one party at least, if you divide the negotiation process, one party, like the husband, suggests first, I will cook today, you clean the house and do the laundry. My wife said, good, then that is the agreement. My wife said, no, I don't like that. I want to cook. Okay? So basically, if you look at the basic element of bargaining, it's always like not both parties suggesting. One party suggests, the husband suggests, wife may say yes, yes, you cook, I will do laundry. Or wife say, no, 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 you do the laundry and cleaning, I'll do the cook. Counter offer. So the first step is the husband offer, I will cook. The wife said no. And wife said, I will cook, you clean up, kind of thing. So basic element of bargaining is one person make a suggestion, the other person say yes or no, accept or reject. So they can do million times, as I said, but I will assume that at 12:30, Sarah makes an offer. Jane may accept or reject. If accept, then that's the end. They eat the pizza as Sarah had suggested. If rejected, Jane waits 10 minutes and only 12:40. This time Jane make a suggestion. Then Sarah may accept or reject. If Sarah accepts at 12:40, that's it. They will divide as Jane has suggested. But if Sarah rejected 12:50, this time Sarah make a suggestion. And then Jane may accept or reject it. Okay, as I said, if rejected by Jane at 12:50, no one eats the pizza. They go to the class with hungry stomach and the pizza goes to the waste basket. Okay? So this is, I don't know, complicated, but this is like this really, really minimal bargaining process. Wow. Can we analyze this game theoretically? Yes, you can, because you learned subgame perfect equilibrium. Okay, this is basically the table of what I have explained. 12:30, Sarah made an offer. Offer is like, oh, the pizza is 100, so let's divide it like 50-50. The sum should be 100 all the time. Jane may say yes. Then it's 50-50. No. Then Jane's turn, 12:40. This time the sum should be 70. Jane said, oh, I'll get all 70, you get 0, something like that. Jane makes an offer. Sarah said, no, no, no. Or yes. Yes, then they divide up that way. No, they go to the next level. And this time Sarah offers. Yes, then they will eat the pizza. No. Then, even though there are slight value of pizza, even though it gets really cold after 30 minutes, still can. But then they have to go to class and nobody gets anything. Okay. Let's see. I mean, in real class, I asked the student, I brought up 2 students, and one would be Sarah, the other would be Jane, and I asked them to do the game in real situation. So look at this game. If you are Sarah, what would you offer? 50-50? 60-40? 70-30? The first number is for Sarah, of course. And when you are thinking, oh, should I offer 80-20? What would be in your mind? What should be in your mind is, wow, if I offer, I'll get 80. Jane, you get only 20. Would Jane say yes or no? What do you think? 20 is too small. Well, let's see. Yes, that'd be great. But if I am Jane, I were Jane, would I say no? Somehow I feel that way. Let's go next step. Jane say no, and now Jane has 70. One thing for sure is Jane rejected 20, so she is about to get more than 20. So she may say, oh, I'll get 50, you get 20. What about that? Jane offers. At this moment, Jane should consider whether Sarah would accept 20 this time. If Sarah says yes, then, that's a great victory for Jane because she rejected 20 at 12:30. Now she gets 50. But if Sarah says no, then we go to the next step. They have 40 only. Okay? What would Sarah offer and what would Jane get? Okay? Let's consider that together. This is the thinking game. This is a thinking game. And think about that. What is your gut feeling to offer if you're Sarah at the moment? The game theory says Sarah should offer, I'll get 70, Jane, you should get 30. That's the backward induction subgame perfect equilibria. Why? Consider this. At 12:50, if Sarah offers, I said 40 to 0, but 39 to 1. If Jane accepts yes, she will get 1. Okay? She has like very low pride, I gave up 39 to Sarah, I get only 1. But if you are grown up, you are a businessman, would you rather get 1 or would you rather say no and 0? Once again, this is one-time game. Sarah and Jane do not know each other. They will never meet. So you go to like far away, like Argentina or Honduras, Chile. You'll never come there. You met someone in Honduras, and the person Sarah in Honduras offers you 1, and you'll never meet Sarah. This would be secret. Nobody in Korea would know that. Would you rather get 1 or 0? I would say yes. So what it means, if Sarah gets, I'm getting 39.5, I'll give you 0.5. Still Jane would say yes. So Sarah at this point would give Jane as little as possible, then Jane would say yes. Even 0. She has no reason to say no because no means 0, yes means 0. On the other hand, mathematically, if Sarah offered 0.1 to her, say yes. Somebody said, what if 0.01? So basically, she would say yes. So it should converge into 0 mathematically. So basically, realistically, Sarah offers very little money to Jane, very little piece of pizza to Jane, and she keeps almost all 40, and Jane still would say yes. Knowing that, backward induction, we are starting from 12:50 and move on to 12:30. Knowing that, Jane knows that any offer less than 40, Sarah will reject it because Sarah can definitely get almost 40, actually 40 at 12:50. So the least amount of offering Sarah would say yes at 12:40 would be 40. So this 40 came from this 40. So offering 40 out of 70, Jane gets only 30. Here, Sarah would say, if I say no, I go on and get 40. If I yes, 40 right now, why not? I cannot gain anything by saying no. So yes. Knowing this, Jane will get 30 at 12:40. Sarah should offer at least 30. And as a result, Jane get 30. Jane would say yes because I'm going to get 30 anyway. Why not now? Sarah, 70, because out of 100, giving her 30. No, of course, Sarah can give Jane 31, but then Sarah's would be 69. In our game theory, nobody would do that. Everybody are extremely selfish. Therefore, the Sarah offers 30, the minimum amount that Jane would say yes, and she will get 70. So, if you play this game, if you answer to your mom asks, what do you expect? You say, according to the game theory, and Sarah, Jane understand each other very well. They are good at game theory. Sarah offers 70-30. Jane say, Okay, as I expected, yes, I cannot do any better than 30. Okay. If Sarah Jane does not understand very well, Sarah or Jane say no and things like that. However, if they play over and over again, then it's 70-30, yes, kind of thing. Yeah, did you find out the subgame perfect equilibrium? If you think yes, no. Maybe that answer, like 70-30, satisfies your mother. It never satisfies me in the exam. You have to say this 70-30 saying yes is only the equilibrium path that I told you. But you have to write down all the non-equilibrium paths as well, which we will study together next in the lecture 22. Okay, this is the end of lecture 21. We are at the end of week 7. Thank you.